Okay, so recall the function as an input-output system like this, right? All right, so so if you describe what a function is, well, function is this is a rule how to make y from x. Okay, so in the case of x and y are numbers, so f is a rule to compute y from x. Okay, so as a rule, it must be somehow a definite. What does mean definite and deterministic? Okay, definite means say this is not something that's not definite. If you give me one, then you give something like, well, maybe one or two or three. That's not definite. Okay, so definite, say if you're given say one, then you give say five. That's definite. Okay, so there's no this or that or other thing. So it must be definite. So definite means that for every x, there is a unique y assigned by f functions. Okay, so this is a functions. Function is all right. So again, if you have f, so like this, x must be inside a set. So y is inside a set also. The set is called a domain of f. The y is a say range of f. Okay. And other representations, you can write something like this. D domain. This is the range. This is the rule. Okay, so x here becomes y. Okay, so f is a function. A function is a rule assigning every x in the domain, assigning a say number, unique, I would say, unique y in a range. Okay, so we write y is something that we assign from x. So this is a rule. That's the main thing, rule. So for example, if we have something like this, equals say 5x. All right, so in this case, the rule is say that say multiply, oh, I would say something like just 2. so that I can easily say that the rule is double the number. The given number. Okay, so another example is, as a rule, you say that, well, this is square the number. Okay, so it's not really depend on what kind of letter you use. You can use X, or you can use Y, or whatever you like. So the rule is independent of the letter used as variable, right? So X and Y called variable. So as a rule, so G, so Z square, okay, or something like, okay, so these three are exactly the same, because as a rule they are the same. As a rule, they are square the number. There's there tells you to square the number. Okay. So it doesn't matter to, it does depend on X, Z, or T, whatever. You may even write this as Y equals, so L, so like there. Okay. Same thing. Rule say square the number, whatever you like, square it. Okay. It doesn't mean because you square becomes this. Well, square. Okay, it doesn't. All right, so that's the okay. So what is domain? Domain is the set of all possible x where f may apply. Okay, for example, if a square, well, we're talking about numbers, so as far as a squaring goes, every numbers can be squared. Okay, number can be squared, then df is here, and so that's all real numbers, the domain. Okay, in contrast, let's see, something like this. There, you can compute this 1 over x minus 1, so reciprocal of x minus 1, except at one number can be computed for any x except 1, right? So df can be written as, well, let's write it down something different. This is new. Real numbers or you can write something like this, right? And x not equal to 1. Okay. And what else? All right. So, for example, okay. All right. You can compute this as long as the thing under the square root sign is non-negative. So the condition is minus 1. Okay. So the domain is x such that x squared and 0. Okay. If you solve this, you get, sorry. Okay. If you solve this one, you get x larger than 1 or x smaller than negative 1. Okay. So finally you get this one. Let's see. 1 and 1. Okay, so this is how to compute a domain example. So just be aware of, if you deal with polynomials, for example, you can compute for any number x polynomial. But if you work with the rational functions, such this one, be aware of what makes the uh, denominator 0. Okay, so we have to exclude the zeros of the denominator, right? And if you work with a square root, right? So make sure that what's under the square root sign is non-negative. Okay. All right. And remember the range. Now we haven't talked about range. Let's go back to square. Okay. All right. What about the range? Well, we know because we square, when you square numbers, then it becomes, the number becomes at least 0. 0 is the least. Okay, so everything's positive. Okay, so now what we determined earlier, that the domain is the whole real numbers, and the range is just this. Okay. Okay, any questions? All right. So you can add, subtract, multiply, and define the functions. Do arithmetic or operations. So that means, what's arithmetic operations? Yeah. Okay. What was squaring? Well, squaring is just some multiplications, right? Okay, so that's, but there is one operations that's particular to functions only. They are not, no counterpart in numbers. All right. So think about this one. If you have a function, say this is function f, this is the range, this is the uh, domain, and this is the range. And then we have a second function. Say this is g, this is d, g, r, g. All right. Okay. So you can, we have in our operations, we call compositions. Um, Composition is applying functions one after another. After another. Okay, so for example, in this case, is there any way we can go from this domain of f to range of g? Well, you apply f first, and then followed by g. Okay, so f. So this one is f first, followed by g. Okay, this is notation. Or you can say this one f, sorry, g follows f, or you can say also g after f, or f before g, or whatever you like. Okay, so that's what it says, that so it goes to there. This is g little o. There's a compositions. Okay, now composition only works if um, oh sorry, in this picture f follow g it cannot be defined this way, right? Because g and then f, well, it doesn't go anywhere. May not be defined. Okay, so it only goes to compositions can be defined if this is the situations. You see, this is the range of f. This is the domain of g. You see if it works if you have intersection. Okay, so just from picture, you see that if domain, sorry, range of G, domain F is not empty. It's not empty. Okay, so let's some example. Do some. Uh, say, okay, so let's do F square, and then G is x minus 1. Okay, so you see that here df is whole real numbers. The range is example, while g, well, you can compute this for any x. So is the same. Right, so let's compute G follows F applies to X, means that all right, so this is F of X square. Okay, so remember that G is a rule, right? As a rule, it says that subtract one, right? So subtract to whatever the number is. And so you subtract one from this one. Okay. And this is okay because it's defined. Since the, let's see, what's the conditions? Oh, sorry. Sorry, the other way around. RG, sorry. Let's look at the picture again. RF intersect DG. So uh, range of F there. Okay. Range of F, whatever comes first, intersect domain of G. Okay. So this goes RF is real, intersect G. This should be G. RF, sorry. Intersect the G. G is R. So this is not empty. Okay. So this is defined. However, if you compute the other way around, you get different things. Okay. So that means F follows G. F applies to G. G is X minus 1. And F says that square the number. Okay, so this gives you, and if you multiply this out, you get x squared minus 2x plus 1. Okay, this also defined because you can find the intersections. Since RG intersect DF is, let's see, what is this? Range of G. G is x minus 1. This is R. Domain of F. F is R also. It's not empty. Okay, define. Okay, so the thing is may not be same as. So really depend on the order, whichever. Okay. This is an example of something that you cannot compute. For example, here we go. Let's see. Let's do x squared plus 5, for example. Okay, and G is um, uh, let's see, square root of minus x. Okay, let's see. The thing here, of course, you can compute the formula. For example, f g. Okay, so the formula, you get the formula. So g applies to x squared plus 5. Okay, so the g as a rule says that uh, put negative, okay, and then take the square root. So there. Okay. Okay. As a formula, the formula exists, but it doesn't make sense. It's not defined. Ever G F if not defined. Why? Because let's see. Uh, let's compute the range. So domain is everything, right? So you can square a number, any number, and the range. Okay, be careful now. When you square a number, you get non-negative number. You add 5, then it would be bigger than 5. Okay, so the range would be at least 5. Okay, while for G, well, again, this is something that you should be aware of, because this is a square root. So you need a non-negative number inside the square root. So inside the square, negative x needs to be non-negative. That means x should be non-positive. Okay, so this is x. And the range, well, range can be anything here. Okay, so let's check this one. Uh, Whether you should remember, just recall this picture. Have this picture in your mind. You have F first, right? Then you have G. Okay. Here the range of F is 5 infinity, and here's the domain for G is infinity 0. Okay, so this is actually the case. So you don't have any intersection. So you try to range of F. Okay, because F intersect DG is RF is intersect DG is, let's see, okay, so this is, you see the formula exists, but the function itself is not defined. Okay, so don't be fooled by formula. Okay, so beware. Don't be fooled by formula. something has formula does not mean it exists. It is defined. All right. So that's how we get the um, function, domain, and range. All right. There are a couple more things about finding range in the domains of compositions, but we'll do that later. At least you know how to compute the compositions. All right. So I'll stop here and leave the rest for you for exercise with Kakemal. Okay. All right. In the meantime, I will. You still need this note, right? Let's see how. Um, okay. I'll let Kemal take over this one. Okay. So I'll stop here and send this note to Teams. All right.
Okay, sir.
Okay. Stop.